So say that you draw a circle on the ground. You tell a friend to walk around the outside, and at the same speed, you walk back and forth across the center, or the diameter, of the circle. How many times will you cross the length of the circle before your friend returns to where they began? You will probably find that for every time your friend completes a lap of the circle, you will walk back and forth about 3 times, plus a bit more. In other words, the ratio of the diameter to the circumference is equal to 3 and a bit. This number is the same for any circle, no matter whether it is the size of the sun or a coin in your pocket. Well, sure, but what application does this have? Well, you can easily use it to help determine the perimeter and area of a circle. For example, if we want to find the perimeter or circumference of a circle, then we use what information we already have to determine just that. If the circumference divided by the diameter equals pi, then it would follow that the diameter multiplied by pi would give the circumference. You can check just to be sure. Next, we want to find the area of a circle. There isn't an obvious place to start, so what we can do is fill up the circle with shapes whose area we already know how to calculate, like a triangle. This of course just gives us an approximation, because the bases of the triangles don't quite touch the circle's arc. We can, however, get a better approximation of the circle's area if we increase the number of triangles. And if we increase that number to infinity, then the triangle's bases will have gotten so close to the arc of the circle that the perimeter of the triangle's bases will be equal to the circumference. We can now split the formula into 2 halves, an h over 2 half and the b times n half. The perimeter of the triangle bases is now equal to the circumference, because the number of triangles is so close to infinity. Now, when we make this half of the formula approach infinity, then we also have to make the second half approach infinity. And this now becomes half the radius. Now our formula is r over 2 times 2 pi r, which then simplifies to the more familiar pi r squared. Here's an example. This circle has a radius of 25 meters, and we want to find the circumference and area of it. All we have to do is double the radius to get the diameter, and multiply it by pi. This gives us our circumference, 157.079632 meters, which we would round to 157 meters. The area, as we've just proven, will be equal to half the radius times the circumference, or pi r squared. So the area will be equal to the square of the radius, 625, times pi, which is 1963 and a bit, also known as 1964 meters squared. But you don't want to stop at boring 2D circles, you want to find the volume of a sphere. You can use a similar proof method as we did for circles to find volume of spheres, except that we need to replace triangles with pyramids because the shape is 3D now. Proving the volume in this way, we get the formula 4/3 pi r cubed. This means that if a sphere has a diameter of 10, you just have to find 4/3 of 125 pi. The answer to this is about 524 units cubed. In case you forgot any of that, here's a summary of the formulas.